We're going to get started soon, everybody. Just letting you know.
Yeah.
Going to give people a few more minutes to roll in, but you are in the right webinar if the webinar you plan to attend was building customized autonomous systems. We're going to be focusing on companion computers and external hardware today, as well as tackling some general integration challenges. Not only do you have Andrew, but we have bonus team members from Ascend in the room. Zach, the other co-founder, as well as Andrew Bryan, who is another engineer on the team. I've actually written an article with Andrew, so I could attest to his skills. I haven't introduced myself. I'm Mike Peel. I'm a marketing consultant. I am working for Ascend Engineering. Been working with them for about half a year now, but I've known them for a while. Zach is popping his camera on, so wait to Zach.
Yeah, sorry. I have a 100-degree fever, so I'm hence why the camera was off. Had to doll myself up a bit.
No,
Oh,
no
yeah.
problem.
And then, Mike, right after this webinar is the West Wing Fan Club, right? So people who are still here waiting for that, stick around, right?
I always took you as somebody who watches The West Wing. It's a very specific type of person. Just to let everybody know, you can send your questions throughout the entire webinar, but if you want your questions to remain private, I'll turn off recording at the end. I'll let you know. So you could send those questions so they won't be saved for posterity and put on YouTube forever and ever. Otherwise, feel free to ask at any time. All right, Andrew, if you're ready to go, I'm ready to go.
Cool. Hi,
Yeah.
everybody. Yeah, welcome to Building Customized Autonomous Systems. We're going to be covering companion computers, external hardware. I'm just reading off the slide. My name is Andrew Wilkins, and I am the CEO of Ascend Engineering. So you can read the tag at the bottom. We help companies develop, optimize, deploy on advanced UAV systems. Like essentially what we do is you can come to us and purchase hours for our software engineers to work on your project. And our software engineers obviously have a lot of experience, knowledge, wisdom when it comes to UAVs and the solutions, right? So we'll be touching on, you can kind of see the experience we have as we go through and talk about these onboard computers and external hardware that we work with. So small company, bootstrapped company that Zach and myself started about 5 years ago. So follow us on LinkedIn and all that good stuff. And then what we're going to cover today, the era of custom drones, kind of high level, what these things are being used for, what people kind of come to us with their needs. And then the companion computer ecosystem, the external hardware ecosystem, the pieces of hardware that we work with that plug into the companion computer. Some integration challenges that we've met and overcome, and then next steps. I'm just going to roll right into this. If you have any if you want more reading material, something, to read over with your loved ones at the end of the night, we we did publish two white papers on companion computers and external hardware. So go and have those a read. Mike put those nice little kind of QR codes up there, so we're pretty proud of those. All right, the era of custom drones. So I'm not going to read over this big blob of text. Essentially, what this is saying is back when drones first started, they were, it was a novelty. Like, hey, you can just kind of take this thing off and it'll hover there, and it was over RC, right? And it had a flight controller on board, but there wasn't very many smarts to it. And then we started getting more of the, hey, you can actually have this thing run a waypoint mission, right? Now, what really we're kind of coming into, I don't know if you want to call it the V2 or the V3 of drones, but it is essentially smart robots in the sky. It's not just a novelty. These things are, like computers that are doing real world work, and have these onboard computers that are doing all kinds of image recognition and making real-time decisions about flight paths. And so that's kind of what we are going to be talking about, this V3, if you will, of the drone era. Yeah, your drone's second brain, the companion computer ecosystem. So we're going to start off going over some of these companion computers. The first one, very near and dear to our hearts, is the Voxel 2. So we work with this a lot. And this Voxel 2 is made by a company called Modal AI, if you haven't already heard about them, on like the blue list, NDA compliant. But essentially, I'm just going to go over why we like working with it. So the number one is you can see here 15 tops AI performance through integrated hexagon tensor accelerator. Here's what that means. You can run image recognition on board. You can run AI things on board. Um, it's super light, 16 grams. It is, I mean, you can see right here, it says swap. So size, weight, and power, right? Size, very small. Weight 16 grams, power 5 volts at 3 amps. So like these things can go into a lot of different drones no matter what the size. They fit nicely without having to change kind of like your whole airframe around it, right? And the reason we really like it as well is like it comes with a lot of different hats and sensors that you can kind of plug into thermal, time of flight, RGB. Um, you can see on here in the image, we have just like a Wi-Fi hat. It's just like a standard one that they have. And we work with it so much as well because they come with a lot of software on board to do GPS denied flight, to integrate with SDR radios, to stream RTSP. Like you can get one of these things and within the first 5 minutes be streaming RTSP through one of the high-res cameras. But it runs PX4 and RD Pilot on the DSP, which is, like just integrated on the board. And like I mentioned, like they have a very robust software that it comes with, SDK and documentation. You can run like Docker, ROS2 on it. I can go on, but this is onboard computer that we work with all the time. NVIDIA Jetson. So the first NVIDIA Jetson that we worked with was a Xavier NX, and that was like 5 years ago. But now the Orin series is really picking up steam. And you can actually look at Arc Electronics. Arc Electronics does a lot with the NVIDIA Jetson. It is swap size wise, it is larger than the Voxel 2. I believe it consumes more power, but it does have more, as you can see here, like these 67 tops, right? Um, so it does have a little bit more performance, but the reason why people might choose the Jetson over the Voxel 2, from what we've seen, is it does run CUDA, right? So there's a lot of open source projects that run on top of the NVIDIA GPU that utilize CUDA. So there's kind of a larger community around it as compared to the Voxel 2, which runs Qualcomm's based GPU and chipset. So they're a bit easier to program on top of. The downsides of this, of just getting an NVIDIA Jetson, is it doesn't come with the supported software that you would get if you bought a Voxel 2, right? Of like, hey, VIO is on board and like RTSP and like all these cool things that are like part of the drone world. It doesn't come with that innately. Now, if you look at Arc Electronics, they are starting to do that. If you're looking at the NVIDIA series, NVIDIA Jetsons, I would definitely look at Arc Electronics because they ship with the Arc OS that does come with like RTSP kind of pre-installed and like these cool log downloaders and stuff like that. So my suggestion would just be, look at Arc Electronics if you're thinking about the Jetson. All right, the external hardware ecosystem, the eyes and ears of your platform. Nice tagline. All right, so we're gonna go over RGB cameras first. Like this is just the IMX 412 is just our favorite to work with. It easily integrates into the Voxel 2. Great image quality. You can change out the lens. I mean, it just works, to be frank. There's a lot of other cameras that you can use out there. And I mean, you can log on to Amazon and get a webcam that you can plug into your drone, right? But this has a lot of options especially when you plug it into the Voxel 2, of exposure, all the settings essentially that you would need to change for your specific use case. I mean, you can even change out the lens with like an IR cut lens and do things with like IR, right? So that's just why we love it. There's plenty of other RGB cameras out there, by the way, but that's like top one in our book. Thermal imaging, FLIR. FLIR pretty much has like the total market share on thermal imaging. I think Workswell has one, but we like FLIR. So like the boson is essentially what we've been working with very recently for all of the thermal camera needs that we have. So good resolution, 640 by 512. You can also get the Hadron, the FLIR Hadron. Now, the FLIR Hadron has the boson in it. So it's the same thermal camera, but it has an RGB camera in it as well. So you can do kind of like image over image of here's the RGB, but then here's the thermal. And it'll be like the same photo. So we love integrating with that. The boson integrates easily with the Jetson because it's USB based. The Hadron integrates very well with the Voxel 2 because they do have this extra MIPI that comes out and they port it over the drivers in XYZ. So we actually did a little video on integrating the Hadron onto a Voxel 2 not too long ago. So you check out our LinkedIn page. I think it should be on there. But FLIR is really oh, the Lepton. I forgot to mention the Lepton. FLIR also has a small little Lepton camera. Lower resolution, but it's just like it's just a few grams. So people use it on their drones a lot, especially if they're like super small, like they're going for super lightweight things, but obviously not as high as resolution. All right, LiDARs. This kind of opens it's just a huge range, right? Because you have LiDARs that return a point cloud. You have LiDARs that return just a singular point, like a rangefinder. If anybody plays golf here, I don't, but that's how I know about rangefinders. Um, and then you also have LiDARs, which are actually, they use lasers, and then you have like time of flight sensors, which use an LED and then measures the return time. So it's almost, when we say LiDAR, but people still refer to those as LiDARs sometimes, right? So it's kind of a very large range of LiDARs when we just say LiDAR. So we're gonna walk through it. The first LiDAR, if you will, is this time of flight sensor, the M0178. That's the camera you see over to the right. And so that returns a point cloud. And it integrates very well with the Voxel 2. As you can see, it's super small, right? But it's just kind of like this image that you get. It's not 360 or anything like that, but you can still use it for like mapping if you wanted to kind of create a 3D rendering as your drone flies around the room. Modal AI has a really cool video of this doing mapping on their website. Here we go, the VL53L1X. I guess couldn't have made it any easier to say, but that's the rangefinder TOF sensor that I mean, it integrates onto the Voxel 2, another one that integrates well on the Voxel 2. It's super small. So that gives you can have it downward facing, and that'll give you your height, a very accurate height estimate of what's beneath you, right? Then we have the Lightwear series. We love Lightwear. They make really good, point to point, like singular point rangefinder type of LiDARs. That's the SF30, SF20, the LW20. And these are just different form factors at different ranges, essentially, is the difference between those Lightwear models. The SF45 is cool because it does, I believe it's 270 degrees, but it basically has a single point LiDAR, but it swivels back and forth. So you're kind of getting the spinning LiDAR, but at a much cheaper and lower size, swap size, I should say. So we like it. The Intel RealSense was a time of flight sensor. It's been discontinued, but we like the RealSense stuff. And then the yellow scan things that we see over here to the right, while we have made software to interact with them, we've actually never personally flown with them, probably because they cost, hundreds of thousands of dollars. So we've actually spoken with a company called Aerovelocity. So we know some of their flyers over there. They're a service-based company, and so they really recommended the Yellow Scan series, as well as, Quantum Systems has integrated on the Yellow Scan. So if you're doing mapping type missions, we would definitely recommend Yellow Scan. And the difference between these is really precision, as well as if they can kind of even go beneath, like tree lines and stuff like that, for like ground, if there's a lot of foliage, it can kind of penetrate that and get really good ground mapping. All right, SDR radios. This is my jam. So SDR radios, we have the Doodle, the Microhard, the DTC, the HearLink. So these are all rather different, or shine in their own areas, I should say. I'm going to start at the bottom. The HearLink is a really good point-to-point, easy to set up, well-supported, well-tested radio. So it comes with like the HearLink ground control station, and then they have this small little air unit with an Ethernet port on the top. If you want to integrate, your external hardware, like a Raspberry Pi or a Jetson or whatever, and a Voxel 2. And it uses the LTE protocol. So even in environments where there's a lot of chatter, it basically just yells louder. For the layman, right? So it's really good point to point. They have a great ground control unit that you can control your drone with. It's easy to set up. Love the HearLink. Now, the DTC radio, definitely a really good radio. They used to be so hard to set up, and they've gotten so much better at setting up their radios. But a good software-defined radio can do mesh. Different like government agencies kind of like that device. The microhard, this is like I feel like this is almost like a tried and true, like forms a really solid point-to-point connection. We've used it for meshing before, but I've heard rumors that it does kind of like almost like you still have to have one kind of like master point to do the mesh. But we haven't worked with them in a while, and I partially think it's because of the form factor. Like I haven't seen a microhard radio that you can just kind of purchase um, off of the internet, right? Off of, whatever, Mouser, and just kind of like get it and then just plug it in and have it work. Or like even a ground control station. They make almost like the modems, but they're not as easy to kind of integrate. You got to do like soldering and stuff like that. So that's been our experience with the microhard radios, but really solid point to point. The Doodle Labs is my personal favorite, to be honest with you. It does meshing really well. They're easy to set up. There's a few gotchas there, like don't use a simple config page. They're getting better at it, but and their customer service is really freaking good. Like when you reach out to them, they will respond, and help you figure out some of your issues if you're having any, or support you and change the setting, do this, do that. So we have a lot of experience with the Doodle Labs radios. I really like them, and I think that we don't have Silvis on this list. We're getting a little bit more experience with Silvis, but I would say that they're probably most closely related to the Doodle Labs radios. Okay, optical flow sensors. There's one big bad daddy in the optical flow sensor world, and that is Arc Electronics. All right, full stop. Like we've used other optical flows, and I think Hollybro came out with one as well. But if you want to go with an optical flow that is like tried, true, tested, it's NDAA compliant. They have like a Discord, so if you have any questions, you can ask them there. Like, love Arc's optical flow, the Arc flow. If you have problems with it, chances are usually it's your drone configuration or it's your hardware configuration for how you mounted it. Kind of full stop. Now they have an SR short range and they have an MR medium range. Alex, we're waiting on the LR, the long range. But really good boards, and like I said, really good support. I really wouldn't recommend any other optical flow. All right, now we're gonna go to integration challenges, things that we've burned weeks on and are putting in the slideshow so you don't have to. So choosing the right hardware, I'm not going to read all this text. You can read it. But essentially what we're saying in here is like, spend a little bit more money on the right hardware. Do not try to be like, all right, well, we'll fix it in software. Like you're just setting yourself up to be burned. Because if you don't buy the right hardware, you buy some like cheap Chinese stuff. And I think this was more prevalent like 5 years ago. When you buy cheap stuff, you're going to spend like 2 to 4 weeks just like trying to get it to work. You're going to get upset. You're going to burn time. Then you're going to buy the right thing and be like, we should have just done that straight from the get-go. So just buy the right hardware. But let's talk about physical integration challenges, signal and interference problems. USB 3 interferes with GPS. I have crashed a drone because the USB 3 wasn't properly shielded and it interfered with GPS. And it doesn't feel great to watch a drone fly one way, about face, and then fly into a tree. So that was when we were first getting started. But yeah, USB 3 can interfere with GPS. And then crosstalk between unshielded cables. I've had a Doodle radio plugged into an external computer over USB, and then my Seek radio was close to it, and it was talking over like 915, and it interfered with the USB connection because like the cables weren't shielded and they were super close to each other. It's like you just need to have things like separate and off to the side. Make sure that they're shielded. Power line noise affecting sensitive components. Like, hey, don't have your radio antenna like right next to an ESC. And then signal degradation over longer cable runs. The longer you make a cable, the tougher, the more interference that's possible for that, as well as some protocols are much more sensitive to this type of interference over longer cables, including your cameras. And then physical and layout issues, weight limitations affecting flight performance. That's pretty self-explanatory. Like the larger things get, the less flight time you'll have. Like we could have autonomous drones, if we put a 20-pound, beautiful LiDAR on top and, essentially a desktop gaming computer with a beautiful GPU that did all this processing. But we have weight limitations, sensor-wise, computer-wise. Like those are the things that are limiting how long you can fly for. So you have to think about those things. Space constraints for component mounting. It's like the similar thing to weight. It's like, all right, well, the larger this component gets, the larger the drone has to get, and then the more scary it is. you know, uh, people feel more comfortable having a 250-gram drone fly above them compared to a 55-pound drone. I'll tell you that. Vibration affecting sensor accuracy. I cannot tell you how many times we've had an issue with flight and realized that it was a vibration issue. Like this is the bane of existence for people who are putting together drones. Like, and it's not like science. You can't just do a calculation. Sometimes, you got to just take it up and see what's going on. Like we've had an issue where vibration on this very custom drone, where vibration to the IMU caused the drone to stop listening to its compass because the compass heading was wrong. And then we had to fly away. Luckily, we took over manual control, landed it safely, XYZ. But it's like these things can happen. I mean, it's like walking down a hallway and having somebody like, bang on the side of your head. You just kind of lose your internal, your inertial. I'm just going to say IMU. It's your internal IMU. Somebody's banging on the side of your head. You're going to have a tough time walking down the hallway straight. Temperature variations, degrading performance. Your computer gets hot, it slows down, right? Same thing with radios. It's the same thing with drones. Except because everything is so much smaller and compact in this device, things heat up quicker. And people aren't huge fans of putting fans in drones, because you can hear it. It doesn't really sound super stellar. Like your phone doesn't have a fan in it that you can hear. But yeah, it affects performance and it can affect range with radios. It can even like slow down your Mavlink stream, which is what's being used for communication. So it's something that you definitely got to look out for. The smaller these components get, the hotter they get at high peak performance, and then they're just very close to each other. And then wire length limitations and signal quality issues, kind of already touched on this. With CAN, you can run wires much longer than you can with like I2C or SPI. That's just the way it is. Okay. Testing and compliance. Interaction between multiple components. Yeah, multiple components, different components speak different languages, right? Whether it's I2C, SPI, they speak at different frequencies. So, and then there are different versions of stuff too, right? You can have a gimbal that talks Mavlink, version 1, and then your flight controller is talking version 2, right? Or the gimbal maker, Grimsy, maybe, is like has their own custom ways of doing things that doesn't align with the actual like standard of how they're supposed to be. Now, like things are getting better, things are converging, right? But it's still the case. It's just like, all right, well, this is talking like an old protocol. Anyway, edge case identification under various conditions. I mean, the drone world is all about just there's just so many edge cases, right? What mode are you in? Um, what sensor do you have? Like, are you flying over water or land? Are you trying to do like terrain fault? Like, there's just so many. What happens in this edge case when this happens? There's so many of those that you have to account for and kind of create like a state machine for, so that you know exactly what the drone's going to do in different scenarios. FCC regulations, yeah, don't emit on certain frequencies. Like, make sure you're using 2.4, 9, 15, or else the FCC is going to have a problem with you. And then ITAR restrictions for international shipping. Yeah, you can't ship certain components outside of the US. And that goes for software as well. You can't just share certain data or certain software with people that are outside of the US. If you download GovQGC, you can't just share that with people. Weight and balance requirements for aviation authorities. I'll be honest with you, I'm not a lawyer. We've been asked to do things to fall under a certain requirements, but yeah, there's certain, well, weight 55 pounds and under, right? You can't fly a drone that is larger than 55 pounds all up weight. So obviously a limitation when you want to add a ton of different components to it. Software and maintenance, driver compatibility across operating system updates. You update your system, you update your OS, now all of a sudden it's not talking correctly to a certain peripheral device, right? I mean, we see this with our phones all the time. We change the firmware, and then all of a sudden an app doesn't work. It's the same thing with drones. API changes affecting software integration. This mostly like affects stuff on your ground control station. You were hitting an API before to load up this certain map. Now all of a sudden the API changed. Your map doesn't work. You don't really know where you're flying. And then firmware update management for multiple components. It's just so hard with drones. On our phones, we open them up, and if we want to update it, we just hit the update button, right? On drones, they're not connected to the internet. Like, not people always talk about, oh, 5G and drones and blah 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 blah. Like, drones really aren't that connected to the internet. Most drones are just you fly them over your radio controller, right? So to update the firmware and all the peripherals on board, it's about managing. All right, we got to take that firmware file, this tarball, and then put it on the ground control station, and then let the user know, like, hey, would you like to update your firmware? They hit yes, and then it uses the radio on board to actually update. So, like, the thing that you got to keep in mind is you got to keep your software like small, because people aren't going to wait on their ground controller for 45 minutes for a 5 GB tarball to download, and then wait another hour and a half for this, software-defined radio to actually upload it and install it to the drone. So that's something to think about when you're kind of like creating this end user experience. Power and performance constraints, increased power consumption, reducing flight time, pretty self-explanatory. I mean, if you have a component that, consumes more amps than a different component, you're decreasing your flight time, right? Voltage compatibility issues between components. A lot of peripheral devices operate over 5 volt, 12 volt. But if you have something that's like 16 volt, now all of a sudden you got to put in like this converter, right? This like step up converter. So it's just another hardware component that's just kind of a pain. Heat generation from power intensive operations, like we said before. The hotter things get, the slower they are. Software defined radios and the computers on board. So the hotter the things around you get, like you're going to feel that. We've had a software defined radio heat up a Voxel 2. That was because they're right on top of each other, and they were just sitting there. Like once your drone's in the air, it's fine. Usually there's enough airflow to kind of cool it down. But people plug in their drones and then they put it down, and then they go and they're texting and they're blah, 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 blah. The whole time the drone's heating up, right? And these things, they're out in the sun, like so they're just heating up, not only because they're internals, but also like they're in the sun, and then you start to have performance issues. And then processing bottlenecks during multi-sensor operation. The tough thing so much about the software that runs on board is these need to happen real time. You can't have an operation happen and then, 2 seconds later you get the output, right? Or input from a sensor and then 2 seconds later you get the output. Your drone is already 10 meters past where that sensor read its input. So these things need to happen in real time and can't be bottlenecked because of queuing. Memory limitations for data buffering. Obviously, like on board, you don't have as much memory as you do for your computers that you have on your desktop. That's just the reality of the situation. Communication protocol issues. Yeah, varied protocols across manufacturers. We just had an issue where a manufacturer had a SPY driver written for one of their sensors, but they didn't have an I2C sensor driver written. And so it's like, all right, well, now this is just incompatible, right? Like we only have an I2C port open, so what are we going to do now? Baud rate mismatches between components. This one's it's pretty self-explanatory, but like I can't tell you how many times we've been like, why aren't these things talking? And then we check the baud rate and they're off, and that's the issue, right? So driver availability for specific hardware software combinations. Again, like kind of how I mentioned before, is there might be a SPY driver, but there isn't an I2C, or or they have their specific, oh, hey, you can use our sensor, but you have to use our specific protocol that we made for it. It's like, great. And then insufficient I/O ports on a companion computer. Let's say you have a motor that talks over UART. Well, there's really only, what, 3, 4 max UARTs that are on a normal flight controller board. So, and then one of them's taken them for the radio, and then another one's taken for the onboard compute. So many times it's like, all right, well, how are these components actually going to fit all in together, right? Now, obviously with CAN, you don't really have that problem, but that is it. And then I think Mike told me that I should hand this back over to him.
Yeah, go to the next slide though, so that we can show people
Right.
how we can connect. All right, if you'd
Yes.
like to connect with us, please visit us at ascendengineer.com. That's ascendengineer, not ascendengineering.com. Web addresses are apparently a commodity, or not a commodity. You can also connect with us on info@ascendengineer.com or call directly at 312-620-9384. If you have any questions, please ask now or raise your hand, and I could give you the mic for a minute to talk with either Andrew Zach or Andrew B. Otherwise, we're going to also send along recording of this at some point within the next 24 hours or so via email, and eventually it will end up on YouTube. But don't worry, if that's not your bag, you could also check out the 2 white papers. All of the content that was in here was actually covered in those as well. So any questions? Yes. Okay. Has there been any cases of processing facilities or manufacturing facilities integrating UAVs into their PLC SCADA system aside from warehousing robots that simply move pallets and such around? More specifically, have there been any cases where you're integrating swarm logic in multiple drones for mission tasking and inference? The situation I'm working on now simply as a side project, but I wanted to know if anybody else was out there working on this type of tasking.
Got it. So I think I heard 2 things in there, which is like PLC and warehouses. And if I'm correct, those PLCs are essentially just like, controllers that are in like warehouses or manufacturing facilities and stuff like that. And then I heard something about swarms in there as well. So the short answer to the PLC is like, no, you usually have to have like a higher level thing that's like coordinating, right? So it's not directly into the PLC, but it's essentially communicating with it to understand where it's at in its like life cycle, right? What stage of the manufacturing process are you in? And then we've done stuff with like inspection in those use cases of, all right, well, this PLC over here is doing this, fly over to this location and check it out, right? And those have been mostly just kind of like they've been demos and like proof of concepts and stuff like that. Like, it is so hard to do um, indoor positioning correctly, um, or I should say accurately, like almost like indoor GPS. But I will say you take a look at BitCray's loco positioning, sixed off that uses LEDs on the ground, and there's some other companies out there that are doing cool stuff in order to actually like get positioning indoors. And when I say positioning indoors, I'm talking about almost like global positioning indoors. So, the bottom left of the factory is 0, 0, and the top right of the factory is whatever, 10, 10. Um, Using VIO or optical flow, you can easily do indoor flight, but those drift over time because they use cameras that are actually on board. And then in relation to swarms, I mean, pick your poison. Drone light shows, uh, multi-tenant control. Like there's just so much encompassing swarm. Um, and then how many nodes and what you want to do and the range. It's just such a broad sector that like there are a ton of people doing it, but it's almost just like, well, what is your use case? Do you want this swarm to go 6 miles and have their own like do surveillance and stuff like that and send you back like, hey, I found something that you asked me to look for? Or is it just, hey, I want 200 drones in the sky at once and then we just want to send them off and good luck. So there's a very large range in there.
Yeah, I guess that question also, given his use case that he's talking about, can you handle it with multiple missions of single drones? Like, why add the complication of swarming unless it's absolutely necessary for the industrial purpose? Um, so, next question. And I'm sorry, actually, Lee, you had unmuted. Did you want to ask a question? Sorry, I muted you.
No, I was suspecting you guys were about ready to sign off. I was just going to say, so far it's been a good and informative meeting, and nice to meet everybody. But yeah, Michael, your questions are particularly interesting to me. So continue, please.
Yep, sure. So next question. What do you advise for a drone running indoor using optical flow sensor by Miko Air?
I
Have
actually
you
haven't heard about
seen
Miko
those?
Air.
I've
Uh,
heard of them.
is that
Um,
is that the company that's based out of India?
I'm trying to remember where I had seen it, but yeah, I think it's more affordable than ARC, which would usually indicate outside the United States,
Yeah,
especially since ARC has such dominance here.
yeah. I'll say this is that every single time this goes back to hardware, right? Is that yeah, it might be less expensive, right? But integration wise, if you have issues, you can go on the Arc Discord and put out a message or email them. And I think that while we haven't had a lot of experience with the Miko Air optical flow, I know that the arc flow is tried and true, so I can speak to it. We've used it in so many use cases. So for us moving forward, even though the Miko Air optical flow might be a little bit cheaper, we're going to continue to use arc because we know it's tried and true, and they offer great customer support when we do have questions about, hey, what's going on in this certain scenario.
Okay, so we have follow up on that, and then we'll move
Yeah.
on to the next questions. So no, the Miko Air is not Indian; it's Chinese.
Ah,
Um, so doesn't light create issues with optical flow and LiDAR facing downwards and also on reflective surface? Well, reflective surfaces are a problem for a lot of different sensors. So Hitesh here is saying that they are seeing drifts.
Oh yeah, no, for sure. I mean, in like heavy light or high gloss, yeah, you're going to get issues with your optical flow sensor. I mean, if you shine a bright light in it, like, yeah, you're going to have issues. So in that particular use case, if you're flying on like shiny ground, I would look at VIO, especially that runs on the Voxel 2 that use multi-cameras, downward facing, frontward facing, backwards facing, so that if you're flying on shiny floors, you're not going to have that problem.
Yeah,
And then there's also some use cases of using multiple optical flow. In fact, we have been working on something that we hope to push to PX4 in the mainline in the near future.
we actually have a tutorial on that multi-camera setup on the Voxel
Mhm.
that I wrote with somebody from the team at Ascend. So you could check out OpenVin's 3-camera setup on our website if you want to take a look at that. Okay, we got a lot of questions, so I'm going to try to move through them. But Michael Baldwin, what are the most promising pieces of hardware and product roadmaps in the NA UAV space you are keeping an eye on?
Does NA stand for North American?
Probably, but let me see if Michael has a follow-up.
Most
He said around new components or drone platforms. Yes, it does mean North American.
promising pieces. That's actually a great question, to be honest with you. I know I talked about a lot about Modal AI and Arc in this segment because they put out great stuff that have great support through Modal AI's forum and through Arc Electronics like Discord channel. When it comes to new pieces, I'm trying to I'm trying to make sure I know kind of like what I'm talking about. It's, oh, you know what? Gremsy, I think, is coming out with a lot of like really good gimbals, and I think their software is getting just better over time, to be honest with you. So while they're based out of Vietnam, I'm really bullish on Gremsy. I think that the Hadron Voxel 2 integration is not getting as much light as it should. I think it's like that is a super powerful combination. And to be honest with you, every single time that I look on the Modal AI store, it seems like they come out with a new component or a new hat that I'm like, why aren't they marketing this more? And maybe it's just because I kind of like know more about it. Um, and maybe people don't know like high level what that component will do. Uh, but then Arc also came out. I mean, I think their Jetson carrier board is super awesome. And I also think that I'm surprised that I don't see more people talking about their Raspberry Pi optical flow, like flight controller kind of combination. I think that it's super cool to just kind of like program on top of that. And then they're also coming out with this dev drone that I'm super excited about that like people will just be able to buy and then just like start programming on. So I like those pieces of
Is
hardware.
that the drone blocks one that they did, or is it a different one?
No, I think it's a different one. I think the Drone Blocks one is a Dev 5 from Momentum Drones. I believe that Arc is coming out with their own.
Yeah, I just to piggyback on that, Andrew, I think like pieces of hardware also like in terms of drones, like Free Fly, for example, like they are manufacturing 18 Astros per week now and just churning those out. And I flew one recently, and that thing is as smooth as butter. So I
And then
think
IFT's new controller as well. Beautiful
Mhm.
piece of hardware that just came out. Sorry, Zach.
Yeah, so all this to say, like within like the small sensor world, I think it's pretty hard to jump outside of like old faithfuls that everyone is like super accustomed to, right? So like the Modal AIs, the Jetsons, the Raspberry Pis, the Raspberry Pi compute boards, right, that come alongside those like 2-in-1 PABs, whether you're buying them like in the US, but the problem is like there aren't a ton of US manufacturers that are selling, Blue UAS or NDA compliant boards that are less than $1,000. So I think like the innovations that you're seeing aren't really necessarily like on like the super small scale in terms of hardware, but more so on the software, and then maybe like small little hardware like renditions that make something twice as powerful. So like Arc Electronics only had the low range finder for the first, 5 years of its existence, and then 6 months ago they doubled the range with a different lidar, or sorry, with a different distance sensor. So I think it's just you're basically seeing like these small little increments in hardware on like the same boards that make them twice as powerful. And yeah, I think also like in terms of, especially with like the hype occurring after the Pete Hegseth video, 3 months ago, I think everyone and their mothers is pretty excited for like FPVs. So I know Orca is coming out with their own 2-in-1 flight controller slash onboard compute that runs Yocto. Similar to like, you can think of theirs similar to like a Skynode with an IMX8 in it, which obviously isn't meant to be as powerful as Modal AI or a Jetson or something like that, but super small swap. And I think people are just kind of like getting into multi-camera optical, or sorry, like Andrew said, multi-optical flows, multi-camera VIO, just kind of unique ways to fuse all this data into the Kalman filter together so that you get a robust flight. So yeah, sorry, I just wanted to piggyback off what you had, Andrew.
Oh, thank you.
Yeah, I'd expect a lot of movement in terms of the capital that's flowing in right now, and also the change to the Blue UAS kind of certification process. Because prior to the Hegseth video and the announcement therein, the DIU is really overwhelmed with the amount of requests. So everything was done in big pools, where I think you'll have a lot more access to getting Blue UAS certified now. So hopefully that'll turn out some things in the next 6 months or so. All right, so how good are VIO only methods, waypoint navigation applications? What are gotchas to look out for? And a follow-up to that, does a magnetometer in the IMU improve VIO significantly?
Okay. Okay, so VIO only. Here's the thing with VIO. If you are there's so many more things that you can do with it. It's really cool. It's just like our phones. Like if you get an Android phone, it's like, oh cool, I can program on top of this, and it's like easier to jailbreak, and like there's all these like more capabilities
Whoa.
that you can. There's
Yeah,
go back on mute, Zach.
for
Go back
legal
on
reasons, Andrew didn't say that.
iPhone or die.
No. So like with VIO, you have like all of these really cool capabilities that you can do, but of course it makes it more complex. Of course it makes it harder to set up and like test and stuff like that. And if you're just like, hey, I just need something to put on the bottom of my drone to do like indoor, like non-GPS flight, get an optical flow. So yeah, VIO, like you can have a solution that does VIO only, but yeah, it's going to be harder to set up. You have to get your extrinsics files correctly and make sure things are calibrated. Make sure your cameras are calibrated. So there's just more steps as compared to like the optical flow, which you can take and then just like slap on the bottom of your drone. And we know solutions that do VIO and optical flow. But anyway,
We've integrated
that's
them.
my we've
The
yes.
the VIO is great, but just like any traditional GPS denied type of system, you will run into the hurdles of like if you're flying over white snow or like a white wall and you fly your optical flow sensor and obviously you're seeing drift, you're going to see the same exact thing with a camera in a completely white room. And
Unless
even if,
you have a forward and backwards facing camera
yeah, correct.
that keeps you
Well,
like on the horizon or something.
so,
But yeah,
right. So the idea being that like how good is it? It really depends on your environment that you're flying in, right? If you're flying in like a very robust, rich area that has a lot of features, shadows, sunlight, horizon, whatever it might be, grass, multiple cameras, so that way if one gets occluded, the other two can take care. Then you should be fine. Running missions purely off of VIO, in my opinion, is I don't think that that's a feature in at least PX4. Like a global, like, sorry, you can send NED based missions. However, doing that, I personally would recommend just doing off-board flight versus a mission. That's just my personal shtick, because then I have more control over what's going into the controller itself. But we're definitely getting too far away from the original question. VIO is great. You just have to like know your due diligence and be cognizant of the environment that you're flying in, because it's just like any other GPS denied type of flight. It has its downfalls. The one thing to keep in mind also with VIO in particular, agnostic of optical flow, right? Is optical flow just connects into your flight controller and then you're done, right? You have to set up some parameters in PX4 autopilot and you're good to go. If you want VIO, you have to buy a voxel 2, or you have to implement it yourself, right? You can either buy like Modal AI's voxel 2 and leverage their open VINs to run visual inertial odometry, or you can buy a Jetson and find something open source and then spend 300 hours making it as good as Modal AI's.
I
So
would argue that it's going to take even more than 300, to be honest with you.
yeah, so all this to say, if you do plan on using VIO, I would personally leverage something that already exists, then start from number one, because you're going to burn a lot of time and money. And if that's the case, you might as well just go to an optical flow sensor that can probably do more or less the same thing for half the price.
Okay, we've got, I think, 3 more questions. What is the best working approach for tuning the new platforms where mathematical model is not existing already? Suspending the platform and tuning manually? What about larger platforms?
Okay, yeah. So suspending the platform and tuning manually. I wouldn't like suspend the platform, to be honest with you. Like, if we want to talk about tuning, like what you should do is you should get really good at flying in manual mode on a small quadcopter. Like, get that down first and then start tuning. And you can go online, RD Pilot or PX4, both have documentation on kind of how to tune. But if you don't know how to fly in manual mode, get that, like, buy yourself a cheap drone and get that down first, because you're gonna, like, it's much less headache, and you're gonna need to take over control of it if things go south. But it's all about starting. I know we have 3 more questions, so I'm gonna say this. It's like it's all about starting at the lowest level and then working your way up. Do the gyro, like do the IMU like filters, like the low pass filters and stuff like that. Make sure that your IMU is getting good data. Make sure that you're not getting too many vibrations, and then work your way up. Rate controller, attitude controller, velocity controller, position controller. But just follow the, I'm not going to sit here and kind of go over each very thing that you have to do. Learn how to fly in manual mode and then follow the documentation online. And then for
And if
larger
that
ones, have a kill switch. Have a kill switch at all times.
and if that doesn't work, call Ascend. So one
Yeah.
more question.
There you
Okay. So can we compensate for the drone drift due to weight on the nose side?
go. I'm trying to kind of go through. Can you compensate in this is like the same thing as we talked about before, is like you want to make sure that your hardware is as best as it can be, right? So I don't know what levels of drift that you're getting. On drones or any type of aircraft, you want the CG centered around the center, right? And that's also where you want your flight controller. But talking about compensation, like, yeah, you can tune it. I mean, is it going to be like, I don't know how much, like I said, I don't know how much drift you're getting. I don't know how much kind of like weight that you have up there. But what's going to happen is if you have like weight up front and the drone starts drifting forward, your optical flow or your GPS, whatever you're using for higher level positioning, is going to realize that you're drifting forward and compensate to move you back, right? Or it's the same thing for level horizon. Like, you're going to realize that you're not level in level flight, and the drone is going to try to compensate in order to get you to level flight. Would I recommend it? Like, no, I would try to work out your hardware problems, right? But are you going to have like a crash because you have a little bit more extra weight on the nose? Like, probably not.